As part of the master planning process for the Nathan campus, we'd identified a fairly limited range of sites for possible building expansions. We have the fantastic natural advantage of the Tui State Forest, but it does place some constraints on us in terms of where we can do campus development and where we can't. So we'd identified a very small number of sites that were suitable for further building development, and happily this site was also a front door site for the redevelopment of the campus arrival space.
It was actually a difficult site. It's a very steep site, it's a really narrow, long site, but then we kind of realised that there's this great opportunity to flank the arrival court into the campus with a building that's really engaging for people when they arrive.
Another happy accident is that its east-west orientation means that it's absolutely ideal for a building where you want to incorporate a slanted solar collecting roof with a north-facing aspect.
The long thin site really worked in our favour as it happened, because it meant you could really only do one space deep along this very narrow site. So what we did is on the ground floor is create a whole range of auditoria and seminar and other spaces that are kind of one space deep, but we could open them out to the street. It's one thing to use the solar hydrogen technology because it air conditions the building sustainably, but also we thought, well, we don't want to just use up all the energy, so you'll see the whole space out there is naturally ventilated, for example, and we don't have any energy going into that at all. The way the building addresses the flow of air is by taking a big glass facade and then breaking it into a series of blades so that air can filter up through those blades at the same time as get wind in from both the east and western directions at the end. So the air is never kind of tunnelling or being funnelled through it. It's being filtered through the space very gently, and that way we get really good fresh air conditions. In truth, we had no choice about the orientation, but it was just marvellous. North, direct south. It's the ideal orientation. So on the south side, no protection needed, can make it transparent as we've done, particularly because it's the way that faces the arrival court and the gateway to the university. That enables people to see very clearly into the activity. On the northern face, it's the sun face where most sun comes. You'll see that all the blades that we have covering the windows have solar collectors on them. So they're doing two things. They're collecting energy at the same time as they're protecting the facade from the glare of sunlight. Then if you go to the roof, we're able to tilt it at the perfect angle, directly facing north, perfect for absorbing the energy.
So in order to make the building work around the energy footprint that was required for the solar hydrogen storage component, we needed to reduce the energy demand in this building to something like 60 to 70% of that of a typical university building. This was achieved through a number of design solutions, including things like much more open plan space and the provision of power over Ethernet for telephone services and computing.
One of the advantages of having a very long, narrow site is that the building could only be 20 metres wide. That means from the north and south it's getting daylight coming directly in, and most times, and as you'll see in many of the rooms in the building, you can operate perfectly well without any artificial lighting at all. And that's different on a cloudy day and at night time, and the building senses those levels and it balances the amount of artificial lighting with the amount of daylighting that's coming in at any one time. Because the roof had to be a really large roof area to contain the number of solar voltaic panels we needed to provide the energy for the building, it also became a huge area for harvesting and catching the water. And so it's this kind of wonderful, almost lake, where we get all of the water and then are able to collect it in a tank. The tank provides the cool water in order to provide chilled water for air conditioning, but it also provides a huge amount of water for operating within the building and irrigating the landscape around it.
There are a range of opportunities for alternative energy use for off-grid building development. One of the attractive aspects about low-pressure hydrogen storage or inert hydrogen storage as metal hydrides is it's very, very safe. There are currently no other buildings of this scale anywhere in the world, so this really is a first in terms of a demonstration project. We know we will have been successful if people come to this building, look at it and think about how they could build a better one.
When you look at it from a visual point of view, I think people can look at this building and say it feels subtropical. It's got a big umbrella protecting it from sunlight or rain, as a person would do. So it really does set a new kind of direction for subtropical architecture in Queensland.